Yes, I'm going to show a demonstration of the implementation of a multi-threaded server. So this server provides two types of operations: conditional read and a write. So in the write operation, uh, the the thread have to update the values of the integers in the array of the server. So the server comprises two kinds of threads. The first one is the main thread that has to uh, create new threads for read or write services, and these threads has to ensure con concurrency for readers and provide exclusive access for writers. So first of all, I'm going to run the multi-threaded server. So now it's running. Then I'm going to run the client side, or the clients I have developed so far. So now we're going to see the output of both programs. So now the client's writing is running. So this is the output of both programs in simultaneous. So the program creates 30 writers and 30 readers according to the constraints of the proposed assignment. So now, as we can see, all the readers have read values from the writer 4, and now only the remaining writers are executing a loop to write data to the server. Okay, now the client side has finished, and the server side is still running. So now I'm going to explain the code developed to perform this, to run these programs. First, I'm going to explain the multi-threaded server. I have created a database thread server class that comprises one socket. This one comprises one socket as a property. Then there is the data inside the server as a list. Then we have two properties: the waiting writers and the waiting readers, that help after to know when to write and when to read. Then I have created some logs to improve, to provide exclusive access to a writing client, and then to improve consistency for accessing these two properties. Then I have created two events to allow readers to read the data concurrently, and the write event to block a writing client before all the readers have written all the data. So by the method start listening allows the object or the server to bind to a specific socket and start listening. So this is the first step here. Then there is an infinite loop where the server thread is the server thread is continually accepting instruction. So by accept instruction, in the accept instruction method, we accept a connection to the socket and then run a thread called which target is the method check instruction. So in check instruction, we know first we receive the data or the data from the client and check whether it's a writing operation or whether it's a reading operation. I will explain later why I use this data type or this dictionary type to allow to ease the reading and writing operations. So in the writing operation, first we lock the access to self-waiting writers, this property, and then immediately release it. And then if it is a writing operation, the thread had to acquire the lock for writing. So after acquiring the lock, it calls write this method. So in this method, the write performs the data writing on here on this property, and then after that it releases the lock for writing. So and then checks whether there is no waiting writers. So if there is no waiting writers, the read event is clear. So this allows the readers to read from the server. So in the case of a reading operation, first it lock the access to waiting readers and then immediately release, and then check whether the read event is set, and if the read event is set, it stuck there until it is clear, and then it read conditionally using this method. This method is described here. So here we know if it is one of these operation or conditions, and then we send the response to the client using this method. Okay. So now for the client side, first I created a data array from 1 to 11 integers. Then there is two IDs, a writer ID and a reader ID, that eases the nomenclature of these clients. Then we indicate or we define the number of clients that we desire. Then I put here two sleep list, or this is a time or delay list for both, for reader and for writer. This allows to know the time between the use of consecutive writers or readers. Then I create a variable called writer probability. So this is the probability of executing a writer or a writer client within this loop. So then I specify the reading condition, and then I create a thread pool executor to manage all the created client threads. So here I just submit the data to the threads, and also in this part I create reader clients threads, and then I save all the outputs as a JSON format, in a JSON format. So I will show how this is useful. Okay, so here we could see the outputs of the readers and writers during these operations in a JSON format. So I will copy this data into a JSON viewer. So now we have 60 clients or 60 objects inside this JSON file. So 30 writers and 30 readers. So first we can see the reader 0. So the reader 0 has a creation time and has a receiving time, and the data that obtained from the server. So this allows to know when the thread was created and when the thread received the data from the server. So then we can see the writer 0 creation time and its writing time, and the data that was written to the server. So there is an interesting situation. For example, here we could see that the constraints about exclusive or preference access for writers is met here, because we can see that writer 1 was created after the reader 2, but it is executed after the writer 1. So this is the creation time, and the writing time is first for writer 1 and then for reader 2, even though the reader 2 has created before. And then we could see that reader 6 was created in this time, and all the readers have concurrent access. For example, reader 4 was created in this time, and reader 6 was created after reader 4, but because it's a concurrent reading, it doesn't matter. So that's all my demonstration.